Hello everyone. Good morning. How are you all? I hope everything is fine. Alright, so today I want to talk briefly about something on regression and correlation. It's about sum of square totals, sum of square regression, and sum of square error or residual. So in this video, I'm not going to take long because I'm even running late for a meeting, but I'll make it brief. Alright, so when we talk about sum of square total, sum of square error, sum of square regression, just terms used in in regression, just to know how or the kind of variability between the dependent variable and the non-dependent variable based on the regression line of best fit, the equation of the regression line of best fit, right? So I want to share my screen, then move on. Right, so I'm coming. All right, so we all know the formula for sum of squared total, sum of squared error, and then sum of square regression, right? So let me say sum of squared total, SST, that's the short form, is equal to the sum for the difference between the dependent variables values minus the mean of the dependent variable values. So always Y is the dependent variable, whereas S is the independent variable. So when you talk about dependent variable, just a factor or a variable or a situation that depends on another. So without the other, nothing will happen to it. But when the other one reacts, then something will affect this or dependent variable. So Y is the dependent variable because based on the value of X, and we're able to determine what the value of what Y should be. So that's the sum of square total. So just the sum of what the difference between the observed value of the dependent variable minus its mean. That's the mean for the entire observed values of the dependent variable. So when we come to sum of squared regression, that's SSR, it's just the sum of what the difference between the predicted value of Y minus the observed values for Y. So the observed value for Y. So that's for the SSR. So the Y-hat is just what signifying the predicted values for Y. So how do we find these predicted values for Y? If we're able to find the predicted values of Y, we're able to know the equation of the line of best fit. So we know that regression, the sole aim of regression is to predict an outcome, right, based on a particular independent variable. So we use regression just to know, okay, we want to estimate in the future what would happen if this changes. So let's say what will happen to sales if the number of our customers reduce. So it's just like using regression to estimate or come out with a model to predict a future value for a dependent variable. So this Y-hat is just the predicted value, and you can only find it when you know your equation of your line of best fit. So, and the last one is SSE, which is if it's called sum of squared error or sum of squared residual. So that's the name. Though it's E, it doesn't mean the SSR is residual. No, the SSE is for sum of squared error or residual. So you have to be careful with that, right? So this one too is the sum of the difference between the observed value of Y, that's the original values of Y, minus the predicted values of what? Y. So don't forget, it says sum of squared total. So all these are squared. You get it? They are all squared. So the SSR, or the sum of squared error, is just, we just want to know the error we made when we're just making assumptions for the Y value. And now that we have a model, we've gotten a predicted value. What's the error between them? You get it? That's the sum of square error. That's just the error between the observed value, what we saw with our eyes, just an assumption. And now that we'll be able to make a model, we predicted the kind of like an exact value for Y. So we just want to know, like, kind of like the variation or the error between the observed values and the predicted values, right? So I said that before you can find the predicted values, you need to know the regression model, or the estimated regression equation. So the estimated regression equation is Y is equal to B naught, which is what the intercept for Y, plus B1, which is what the coefficient of X, times X. So this is if you want to find the estimated regression model, then when you substitute the values for B0 and substitute the value for B1, this error term will not be there in the estimated model. So this is kind of like a specified model. So this error term here is just telling us that there could be situation where we can make it an error, a minor error on our predictions. It's normal because something is a dependent variable. It might not depend on only one thing. There may be other factors that might cause, let's say, sales to fall. Not only the number of customers reducing, but sales could fall for a number of reasons. Maybe low advertisements, but they are not the main factors. So that's kind of this error term just being represent all other factors remaining constant in this particular regression. So it is kind of like a linear regression. So how do you find the B naught? Before you can find the B naught, which is the intercept for Y, you need to know what B1. So you find the B1 first. Then you see in case they'll say using the least square method, find what B1, or they find the coefficient of X and then the intercept of Y. So what does that mean? So when we talk about the least square method, it's just the method we already know when you are finding for the B1. It's nothing different. So it's just the covariance. So I'll just shorten it, of what X and Y all over the variance of what? The variance of what? X. So what you mean by covariance? You mean that, so it's kind of like in the normal way, when we are finding for the coefficient of X, in the normal linear model that we know that the A is equal to what? Change in Y over change in X, right? So this upper part is like covariance. Now it's not only depending on only X, but I'm trying to find the variability between X and Y. You get it? So here is not only the Y that you're looking for, but it's kind of like a regression model. So I find the variability between X and Y divided by only the variability in X to know how Y, the extent to which Y depends on what X. So this covariance is just what we already know in our, when you are finding our correlation coefficient. That's the X minus X bar rather. So X minus X bar times, so let me open this up, times Y minus Y bar. So this is kind of like a sum. So you always bring the sigma. There is an N here and there is I down here is equal to 1, telling us that it will start from 1 and end at the sample size or the sample space. Then you divide all this by the variance in what x, which is x minus x value all squared, right? So that's basically the formula. That's when they ask you to use the least squared method to find the coefficient of what x. Use this formula. I hope you can see, but I know you already know the formula, so it's not a big deal. Just let you know that's the name, the least squared method. Okay. Okay, so after finding for the B1, so already when you are given a correlation model, regression model, and then in the question, they expect you. So sometimes you have to know the question before be able to derive, okay, I'm supposed to do this, I'm supposed to do that, or not. So if let's say they expect you read and you realize that they expect you to draw a table, find for draw a table for x, for y, x minus the x mean, x minus x mean all squared, you get that. So when you're able to draw that kind of table, if it's expected of you, and you're able to just fix in the values here and find the B1. When you're done finding the B1, then you come and find the B naught. So all these, you need to know them before you're able to find the predicted value. And in most questions, you always find the regression equation before you are asked to find SST, SSR, SSE. You get them. So sometimes in some questions, they don't expect you to find a predicted value and all that. They have other factors or other ways of finding for SST, SSR, SSE using the ANOVA. Yet, so in that case, you really don't need all these. But in case you're not given that and you're expected to find for SSR, SST, SSE using the table, then you need to find the y hat, which is what the predicted values of y. Get it? So the B naught is just simply the mean for y, the y values, minus the B1 that we found for times the mean for the x values. So that's basically how to find the B naught. We are done, just substitute it into the equation, but this error term will no longer appear in the estimated model. It only appears when you are just specifying, defining the model. But then when you input values, usually we don't include the error term because I don't know if they are yet to give us a formula for error term. I'm not sure about that yet. But then you don't include that in the estimated value, in the estimated regression model. We are now finding your estimated equation using this, then you can find the predicted values of y. How do you find the predicted values of y? All you just need to do is what? Pick the x value, which is already in the question, while ignoring the y value in the question. So those are like the observed values, what they saw without using any actual figures. They just observe the values like, oh, okay, if y increases by this, or obviously, if let's say if customers increase by this, obviously sales increase by this and that and that. They just observe this based on a particular trend. But then now that we found the model, we want to know the predicted value, because the regression equation is kind of like helps us to minimize the error in our observations. Get it? So that's basically so I'm not going to solve the question also. I just want to explain that at least we know what the y at what actually means. But I'll show you a picture or something about how all these boils down to it. Okay. So and when you pick the x value, come and put it in. Now you get a new y value, right? That become the y hat values, and you find all of them. When you are done, you come and find y hat minus y minus y hat. Then you're squaring them, just like how we prepare the table. You get it. So I'll be able to come out with what this SST would be. So usually the SST usually is easy to find. So you just the SSR and SSE that you have to find the predicted values of y. Don't forget it's what sum of the squared value. So don't estimate that, oh, okay, so if I'm able to find the y hat or the table, then y minus y hat, the sum and that. Now just pay no, you'll be wrong. Whenever each value observed for the y hat minus y or the y minus y hat must be squared first. Then at the end, you add all the squared values to get with SSE or SSR. So that's basically about SST, SSR, SSE. When you know SST, you know SSE, you can definitely find SSR, provided you what make the right calculations. So that's basically for SST, SSR, and then SSE. So the y-axis is not something difficult. It's just the predicted values of y. Just knowing that, because the regression model just make predictions of what will happen in a particular dependent variable if an independent variable changes. So we want to know what the variability between these predicted values and the observed values as the SSR. Now, SSE, what was the type of error we made in our observation? We want to know the extent of the error we made in observation. That's SSE. That's sum of squared error or sum of squared. So yeah. So that's basically for. So I want to show you just a picture. So this is kind of like how if you're asked to draw a table for regression, correlation, regression, if you're expected to do that, then you get something like this. So you realize that this side is what the y hat here predicted values, right? Then the y1 minus y hat, the y minus y hat, that will give you the what the difference between the predicted values and the observed value. When you're done, you need to square each of them. So don't assume they added all this. No, they squared each before they got this, because it's just a side, and then they want to save space and whatever, but they squared each of them. So if you don't want to get confused, you just bring here y minus y hat all squared, then you square each before adding, then you get this value. Get it? So you can try your hands, you can just pause and then try and use this table, because from this table you get all the information you need to find your B0, to find your B1, to find your regression equation, then you know find the predicted value, see if they conform with what is here. Then when you are done, don't have that table for what the y minus y hat squared here, and see whether you get this sum. Then when you know your SSR, you know definitely you can, if you know your SSE, you can definitely know your SSR. So that's basically for SST, SSE, and SSR. Right. So I hope this video really helped out to help explain these SST, SSR, then SSE. So always know that you can also find the R squared from this. So if you know your SSR and your SST, you just divide your SSR by your SST to know your R squared. You get it? So that's basically it. So thank you so much for watching the video. I hope this explanation helps you as you study further, whether for examination, a test, and all that. God be with you. God bless you. Don't forget to like, share, subscribe to this channel. Thank you so much. So let me stop share. Enjoy your day, and don't forget to pray, read your Bible, forgive others, and as we are in the Passion Week of Christ, let us observe it. Let us follow what Christ did, Christ's example in this world. Let us do our best to be our best. God bless us all. Till next time, let's bye for now. Bye-bye.